The surface of the ocean absorbs about 90% of the sun's energy that hits Earth's surface. So when it comes to regulating our planet's temperature, the ocean is kind of a big deal. Hi, and welcome to this channel. When sunlight hits the ocean, some's immediately re-radiated back into space. Some's absorbed by the top layer of ocean water, which causes temperatures to rise slightly. And some's absorbed by the water vapor in the atmosphere, which forms clouds that reflect sunlight back into space. This helps keep Earth at a comfortable temperature for life as we know it. But how does the ocean move that heat around? Warm water tends to float because it's less dense than cold water. So when the sun heats surface waters near the equator, they spread out toward the poles. At the same time, cold water from the poles sinks and flows toward the equator. These currents distribute heat around the globe and play a huge role in the climate of every region on Earth. But these currents aren't random. They're driven by wind patterns that form giant rotating eddies of water called gyres. Most of the ocean's heat is moved by two giant subtropical gyres located at about 30 degrees north and south latitude. These are Earth's major heat distributors. The gyres in each hemisphere rotate clockwise and counterclockwise respectively, moving warm water away from the equator and cold water toward it. At the poles, cold, dense water from the ocean's surface sinks and begins a long, slow journey toward the equator. But not all ocean water is created equal. As it turns out, the water in the Southern Ocean between Antarctica and the other colder southern latitudes is extra dense. That's because it's saltier. More salt means more ions, which makes the water more conductive. So more heat is re-radiated back into space instead of being absorbed by the water. Less heat gets absorbed, so it cools and becomes denser. And when it reaches a critical temperature and salinity threshold, it sinks and starts heading north. This sinking cold water from the Southern Ocean is what powers the giant conveyor belt of ocean water that circles the globe. It mixes warm and cold water and plays a major role in our climate. It takes about 1,000 years for the entire conveyor belt to make one full circuit. But without it, many regions of the world simply wouldn't be habitable. And here's why: the conveyor belt isn't just made of warm and cold water. It also carries along tiny particles of rock, dirt, and living things like plankton. As it moves through the Southern Ocean, it picks up carbon dioxide and other greenhouse gases from the atmosphere. Then as it travels north, much of that carbon is stored in rocks and sediments on the seafloor. But if the conveyor belt slows down or stops, all that carbon will stay in the ocean and our lower atmosphere. So what could possibly slow down or stop the conveyor belt? Well, as Arctic and Antarctic ice melts due to rising global temperatures, fresh water is added to the ocean. More fresh water means less salty water, which means it's harder for that water to sink. In other words, melting ice could slow down or even stop the conveyor belt and disrupt regional climates. Since the Industrial Revolution, we humans have added 4.5 Hiroshima atomic bombs of heat to the ocean every second. And 90% of that extra heat has gone into the ocean. Surface waters are now about 1 degree warmer than they were in 1900, and since the 1970s, we've been adding 4.5 Hiroshima atomic bombs of heat to the ocean every second. And it's not just the temperature that's changing. Rising air and water temperatures are causing ocean levels to rise, altering coastal ecosystems and threatening island nations. But the ocean is still our best defense against the worst impacts of climate change. Even though it's taken up 30% more carbon dioxide since the Industrial Revolution, the ocean has absorbed about 90% of the excess heat we've added to the atmosphere. So to wrap your mind around just how big of a deal the ocean is, consider this. If the ocean were a person, it would have a mass of 1.35 trillion metric tons. That's 1 million times heavier than the Eiffel Tower. If the ocean were a country, it would be the largest country on Earth, almost 7 times larger than Asia. If the ocean were a pie, it would make up 70% of Earth's surface. So yeah, the ocean is pretty big, and it's our responsibility to take care of it, because if we do, it will take care of us. So thanks for watching. See you next time.